Hi everyone, we'll be following up on the topic we looked at in the last class, steam as a working fluid. In the class we saw the fact that when water boils that it can go through different stages to form different types of steam. So we started by looking at the fact that you have your water, which with increase in temperature gets into what we call wet steam, and this point is what we call the saturated point. However, we also indicated the fact that based on your PVT relationship, we know that there is a direct relationship between pressure and temperature. So it infers that the boiling point will vary with temperature. Boiling point varies with temperature. So with increasing, so what that means is that the boiling point boiling point necessarily isn't 100 degrees C for steam. So with at different points we can have, if we vary the pressure, the boiling point can vary, will change. So it's only at one atmosphere that we have atmospheric pressure that we usually have the boiling point as 100 degree centigrade. So just recapping from what we saw in the last class, so we'll see here that so we have water when it's at 0 degrees C, getting to the saturated point here, and then over a period of time we have what we call wet steam, and within this period, within this range of wet steam, you have your water as liquid coexisting with steam as vapor or as gas. You have that coexistence, so that's why it's called wet steam, until you get to the final point here where you have dry saturated steam. And then beyond that, and I want you to also take note of the fact that the temperature within this range, the temperature doesn't increase. The only thing that changes is the specific enthalpy. So you see that the specific enthalpy changes. The second thing, not the only thing, the second thing that changes is the dryness of the steam, which we measure with X. So you see that the dryness, when it's closer to the saturated point here, the dryness is very low, and as you get to the dry saturated steam, your dryness is equal to 1. So take note of that. And then we have what we call superheated steam. But also another thing I want to take note of is once we get to the superheated steam, the pressure, so the temperature might increase. Take note of this. From the saturated point to the superheated point, the temperature might increase, but the pressure is going to remain the same. Take note of that. The temperature would increase, but the pressure will remain the same. And so we have that step from dry, saturated to superheated. So take note of that. And there we'll be encountering these different notations as we move on. So take note of what we've seen here, and so let's look at some examples to consolidate this knowledge. So also take note of this. So X, dryness fraction, which I've talked about earlier on. The other values will be seen as we move on are HF values and HFG values. So let's look at example 10.1. Example 10.1, it says on temperature enthalpy axis. So temperature enthalpy axis is what we've previously shown. So you have enthalpy here, you have temperature here, and alongside temperature you have the pressure. So take note of that. 1 kg of water initially at 0 degrees C is brought to the boil at 100 kPa and converted to wet steam having a dryness fraction of 0.9. So that is our X, this is our P, we have our mass here, and then we have our first temperature there. So let's move on. So I've drawn the temperature enthalpy. I've drawn the temperature enthalpy graph here. So you remember we started from 0 degrees C, and then the question says that we moved on to 100 kPa. I want us to take note of that. So what we are given is the what we are given is pressure value. We were not given the temperature value at that pressure. So how do we get this? How do we get this? That is where what we call steam table comes into play. Steam table. So let's look at, you will always be provided a steam table. So remember, the pressure we are given is 100 kPa. So we have the pressure here. So let's look for 100 kPa there. And if you look at it, the equivalent temperature is 99.6. Remember, I said we'll be looking at HF values as well. We have HF value 418, and we have the HFG value 2258. So that's how you use the steam table. The way the steam table works is also, if you are given the temperature, you can, from the temperature, vice versa, you can find out the equivalent pressure, and you can also know the equivalent values of the HF and HFG. All right, so having noted that, let's go back to our question. So that's how we got this 99.6. So we've put the 99.6 there, and so you see that it's almost equal 100 degrees C. So that's why we typically say the boiling point of water is 100 degrees C, because that is at 1 atmosphere. So take note of that. So we have this. At 100 kPa, we've seen the equivalent temperature is 99.6 degrees C, 99.6 degrees C. So we've seen that. So 99.6 degrees centigrade. So we've seen that, we've indicated that you've been given, this has been given in our previous lecture slide. So we have this equation in our previous lecture slide. So the Hx equals to that. Remember, we got the HF value at 99.6 from the steam table. So that is that. We've got the HFG from the steam table as well, 2258. So we got this and those. And that. So that's how we plug those two values in, and then our Hx value is that. So remember, we are given the X, which shows the dryness fraction. So that's how we got that. And the considering this question, you need to ensure that remember, the question talks about on temperature enthalpy axis, show what happens. So what that means is, as you've done the calculations, you need to ensure that everything reflects on the graph. You need to ensure that everything reflects on the graph. So you see, we've put this there, we've put that there, all the values are reflecting there. So let's look at the second question, or the B part. So the B part says the same for the same amount of water, 1 kg of water initially. So you can see for this particular one, it has gone beyond 0 degrees C. So it has gone beyond 0 degrees C. So initially 65 is converted to dry saturated steam. So if you remember from what we first saw, we have water at this point. We have boiling or saturation at that point. We have wet steam at this point, and then we have the dry saturated at that point. So we have the dry saturated at that point. So let's look at what we've been given. So we've been given the 350 kPa, similarly to what we did for the previous question. We need to look for what is the equivalent temperature. So you go to the we need to go to the steam table. Let's go to the steam table, 350 kPa. So we have 350 there. Let's look at the equivalent temperature, 138.9, 138.9. And then if you look at the HF value 584, HFG value 2147. So let's take those values back to our question. So 138.9, we've plugged it in here. So that has been plugged in there. So check the properties. So here I've from the steam table, we've done that. And remember, because it's dry steam, from what I showed in the very first on the very first page, x is equal to 1 for dry steam. X is equal to 1 for dry steam. So we have the p value, we have the ts value, we have this, we have those, we got all these from the steam table, which you will always be provided with. So we got all those from the steam table, and also from the lecture slides we've been given this equation for dry steam. So if you plug in those, if we plug in the values we have, remember, unlike the previous scenario where the movement was from 0 to the saturated point, for this particular case, there was one level before the saturated point. So based on that, we need to ensure that we consider the 2 points. So for the HF at 138.9, we've gotten that from, remember, we got that from the steam table 584, but we don't know the HF value for 65 degrees C. So we need to go back to the steam table. So what we do is we look at the temperature point, at the temperature column, we look for 65 there. So what is the equivalent value of HF and HFG at 65? 272. We have that as well. So we take those two values back, 272, so there. So that's how we got that to 72. And remember, because we moved from 0 degree C to 65 degrees C. So that's what, we moved from, rather, let me take that out. We moved from, we moved from 65. We moved from 65 to 138.9, 65. So that's how we came about that. And then we know that HFG at 138.9, 138.9, we know that that is this. Let's go back and check. Okay, yeah, we have it here. So we've plugged that in, and then that gives you your answer. That gives you your answer. So like I said, ensure you plug in everything into the table. Everything you get, ensure you plug in into your graph rather. So let's look at 10.1c. It says 4 kg. Take note of this time around, for the changes that is occurring here. And this time around, we are moving to superheated steam. Remember, from the previous one, we looked at dry steam. This time around, we are looking at superheated steam. It says at 300 degrees C and 2 MPa are formed from water initially at 72 degrees C for superheated. So we started at 72 degrees C. Superheated steam, let's go back. Let's look at how it's superheated steam at 300 degrees C. Just making sure that it's so this should be 300 degrees C. At 300 degrees C and 2 MPa. Remember 2 megapascal. That would be 2000 kPa. So if we go back to our steam table, we need to find the temperature at 2000 kilopascal. That is there. So the temperature is this. We can as well take note of the HF and Ag values if we need them. But the first thing we want to take note of is the equivalent temperature, 212.4. So we've plugged that in, 212.4. So it says from 212 to 300 degrees C. So that is the change in temperature. But remember what we said earlier on. Once you get to the dry steam, the pressure remains constant. The pressure remains constant. So that's why we have 2 MPa at those 2 points. So we've taken note of that. So we have the 2 MPa, 300 degrees C, our mass is 4 kg. We also have our for the superheated steam, we have a CP value which has been given, the specific heat capacity which has been given. So let's look at what else do we need. So at 72 degrees C, you remember it was initially at 72 degrees C, so we need to find out the HF values at 72 degrees C. HF value at 72 degrees C. Let's go back to this. Where do we find? Okay, there. Let's use this. So 72. There we go. So at 72, the HF value is 302. We have all those 302. 302. So please take note of that. 302. So at 72, there we have the HF value. So let's plug that in. We've been given this equation from the lecture slides. So please check the lecture slides. So if you plug everything in, we look at we say changing our we look at the changing H will be HF, similar to what we did previously for the change in temperature. So we found the HF at 212. HF at 212. Remember, the HF at 212 is 908. So we have that here. HF at 72, we just trace that out from the table, 302, plus HFG at 212.4. At this point, we've also gotten that from the steam table. So that is that. The CP value we've been given, and then we know the change in temperature from saturated, from superheated. This is at when it's superheated, and this is when it is saturated. So that point. So if you plug those in, then we have that value. We have that value. So please take note of that. Let's look at the final. Let's look at 10.2. 10.2. Determine how much heat is required to convert 6 kg of water at a pressure of 680 kPa and temperature of that to superheated steam, having a temperature of this and pressure of 680 kPa. So let's go to our table. So we've been given this equation. Check the lecture slides. So we've been given that in the lecture slides. So based on that, we know that we move from 163.8 degrees C. So we have this at a pressure of and the temperature, so 680 kPa. So we need to look at what is the equivalent temperature at 680 kPa. Let's look at our steam table again. 680. So the equivalent temperature is 163.8. So you might take note of the HF value, HFG value. Temperature noted 163.8. So let's go back there. So that is why we've written this there. So 163.8 so we've noted that 163.8, and then at 163. That is the temperature at 680 kPa. 163.8. So that's how we got this. And then the HFG at that point was 692. So remember, we got that from here, 692. And the HFG at 150.3, if you do the same thing, you're going to find that. So that is there. Let's spare some time on that, but you can get that from the steam table. So same thing, if you put in the HFG values there, this is a CP value, and then you get that. So you're going to arrive at that. So our change in H will be equal to this. And then Remember what we've been asked to calculate: how much of the enthalpy of the superheated steam is stored as internal energy. So we need to look at how do we relate what we have with internal energy. So we remember that, recall, change in H is this specific. We have the specific value multiplied by that. So that's how we came across this. So the change in enthalpy of the superheated steam is 13.3 megajoules, 13.3 megajoules. And also recall that the specific, so this is the equation that relates specific internal energy of the superheated steam to the enthalpy. So if you plug in all the values you've been given, then we'll be able to arrive at that. So you'll be able to arrive at that. So the main thing I want us to take note of here is how to use the steam table, how to correlate the values on the steam table. And this is what you've been given here for as practice. So this is just a practice. I won't bother going through this. So what you've been given here is, so for example, when you know the P value, what is going to be the TS value, you can trace them out from the steam table. So please use this as practice, just to ensure you know how to use the steam table. So if you have any question regarding this these examples, don't hesitate to send me a WhatsApp message, or you send me an email. All the best. Cheers.